Welcome to this edition of Momentum TV. I'm Robert Green, your host. We're lucky today to be joined by Professor Emeritus of Mechanical Engineering, Dr. B.K. Hodge. Dr. Hodge, welcome.
Thank you.
Glad to have you here. Dr. Hodge and I, despite our youthful appearance, go back several years, more than you might imagine, but we're very happy to have you here today. A few weeks ago, there was an announcement made that one of your former students, Michael Hall, endowed a scholarship in honor of you and recognizing the impact you had on him and in his career. How does that make you feel about having a student do something like that?
Yeah, that was really a surprise. When Michael visited my office, he says, I just want to talk to you about this scholarship that I'm fixing to endow. And we talked a while, and I said, oh yeah, Michael, that's a good idea. I really like what your plans are. And then he said, well, the real reason I'm here is to get your permission to name it after you. And I was just pretty much flabbergasted at that point.
Yeah, but that was a big honor and certainly well-deserved. I know you had an impact on me as well as a student. So you've been around the university for a couple of years.
Right.
What sort of impact have you seen scholarships having on students?
And I think at Mississippi State, and it's really significant because we're still getting a significant number of students who are first or second generation college students. A lot of them are from backgrounds that were it not for financial aid for scholarships, they would be having a much more difficult time and perhaps not even be here. So it's hard, I think, assess not to think that's a good idea.
Yeah, I would agree. We've seen a tremendous impact of those scholarships on students, and in addition to financial aid. So, Dr. Hodge, you have a rather interesting background that got you here. A lot of students would be surprised. They're trying to figure out what discipline of engineering do I need to have. So being a former professor in mechanical engineering, I think most people would be surprised to know that you have a bachelor's and a master's degree in aerospace engineering. And you also did time in the Air Force Reserve, and the Air National Guard. What persuaded you to make the change from aerospace to mechanical engineering? Well,
Robert, I jokingly say that at some point in my career I found out that everything didn't have wings. The first job I had in the aerospace industry was working on the so-called internal ballistics of solid propellant rocket motors. And the people in the section were about 50-50 aero and mechanical. And when I went back to graduate school, I went in mechanical because I thought it gave a wider basis for possible job opportunities and subjects. But I've still kept a lot of aero involvement. I've been a member of the American Institute of Aeronautics and Astronautics for actually more than 50 years now, and I'm an associate fellow there, and I presented a lot of papers at AIAA meetings, so I haven't lost that connection. And I spent the first 5 years after my PhD working at an Air Force Research Center as a civilian employee, basically doing high-speed heat transfer. And I just found out that what I do is fluid mechanics and heat transfer, and it doesn't necessarily have to have wings.
Well, I'm certainly glad you made that decision. You and I first encountered each other when I was a graduate student.
Right.
And I think it was one of the first times you were offering your energy systems design class.
Right.
I have to admit, it was one of the most useful classes I had in graduate school, and one I certainly used throughout my career. What possessed you to go about developing that course? What was the genesis of it?
Well, when I first joined the faculty, the ME department had a faculty planning conference the May of the first year, following year. And the then assistant department head said, we really need to put in an energy system design course. And I was kind of like, oh, let me. And it turned out that was probably the most fortuitous thing I ever did, because the impact it's had on my career is just almost unbelievable. At that time, there were very few energy system design courses available. Most mechanical engineering education in the thermal sciences ended at heat transfer, which is essentially a basic course rather than an applications design course. So it was a really good idea, and particularly at Mississippi State, where a significant cohort of our graduates go to the petrochemical refining industry, it's a very useful course for a lot of them, and it certainly, as your job experience proved. So everything just came together.
So I remember taking the course, and of course back then we were living in a different world, and I still remember getting a copy of the orange Crane Technical Paper 410 with all of those factors, and we were doing a lot of stuff by hand looking up charts and all. Things have certainly evolved. Can you tell us a little bit how that course has evolved over time with technology?
Yeah, I've actually written a couple of papers on that, but the first edition of the Energy System Design book was essentially set up that had all the stuff in there, all the material, all the mathematical development, all the things you needed to work a problem. But essentially it was, as you pointed, calculator based. You sat down with a sheet of paper and you did it. The second edition had a lot of computer programs in there based around what was then the common denominator for Microsoft, which was Basic or Quick Basic. And that had a measurable difference on the course, because now instead of having problems that you had to think about, well, how long is it going to take to do this? And what happens if you make a mistake in the first step? With the computer program, you didn't have that issue. And then the third edition went to MathCAD, which says, okay, here's stuff now that you can do a lot of things with very limited instruction. You can carry units. So as you go from the first to the second to the third edition, the problems became more involved and a good bit more realistic. So it's had a huge impact on that.
Yeah. So I've enjoyed the textbook. Of course, I like to say I took the course with the 0th edition.
That's right.
It was photocopied pages, and then you developed that into, as you said, now the 3rd edition of the book.
Right.
Tell us a little bit about the process involved in writing a book and having it published and going through the multiple editions.
Yeah. Well, it's gotten more difficult over the years. Lots of copyright issues. I think the way I did it was I knew about what I wanted to do in the course, so I collected all the material I could. In fact, I got a National Science Foundation local course improvement grant that allowed me to buy a lot of books and things to help in the course. And so I had several notebooks full of material that I think I needed to put in there. So you kind of sift it down, and then you realize that 400 or 500 pages of manuscripts probably turns out to be 225 or 250 pages of text. So you go through that, then you go through the editing process, and then the real drudgery comes when you have to get permission to print all of these figures that you get from companies. It's not that they won't give it to you. It's for a company like GE, it's hard to find somebody that will have the authority to say, yes, you can do that. So it's just a multi-step process.
Well, I'm glad you went to the trouble. I know the book has had a huge impact on thousands of students, so I'm glad you did that. I do recall one thing when we first took the class. You surprised me when we walked in, and it was just, I think, sort of an off-the-cuff remark you made. You said, I think you all need to read The Third Wave by Alvin Toffler.
Yeah.
And I thought, what in the world does that have to do with energy systems? But
yeah.
As you and I have gotten to know each other, one of the things we share is a love of reading.
Right.
Tell us some of your background. How did you go about learning to read books, and what value do you see for engineers of reading books like The Third Wave, which is not really a technical book, but certainly an influential book?
Yeah, there's a lot of that goes around. I one time told the students a couple of years ago, well, I think you need to get this book by Mueller that says what the president ought to know about energy. It's kind of a popular base text, not terribly involved with math and engineering, but it's got a lot of facts in it. And right now there's a book out by a guy named Noonan that says settled ? And it deals with an assessment of what all the climate change models are meaning, what the uncertainties associated with them are, and so forth. There's a book with a rather humorous title out I'm reading now called Was God a Mathematician? And the notion there is that why does all of this stuff that we use in engineering and physics in the equation realm, why does it all work? It's all out of products of our imagination. And as this guy said, somebody asked me that one time, and I just said, oh, God must have been a mathematician.
There could be some truth into that. So other than that book, what are you reading now that's interesting?
Well, I read a lot of I guess you'd say, contemporary fiction. I read a lot of all the Baldacci books and things like that, just for, I guess, just for entertainment. Because since I retired, I have more time to read, and some of it is not what you would call great literature.
But sometimes that's the most fun to read.
Yeah, Baldacci, I don't think that's great literature, but he's awfully entertaining.
Yeah. So Dr. Hodge, you came here as an assistant professor, and I know it seems like just yesterday.
Yesterday, yeah.
So you and I both have been through a lot of changes, both in the engineering profession, in education, as well as here at the university. Are there any particular things throughout your career that you think have been more impactful than others?
Well, one of the things that there's been a whole change, I guess, in the faculty culture. When I came here, the expectation was that research and teaching were kind of co-equal in some sense. And I think in the years that since then, research has been assessed as what really faculty need to be doing to some extent. I think that's been a change. And I think just the sheer numbers. When I came here, we had 350 mechanical engineering undergraduates. Now we have 1,100. And that said, yeah, you got to do a lot of things different when you go from class sizes of 20 to 30 to class sizes of 60.
Yeah, things certainly have changed. And
yeah, the current, every generation of students that we get are more adapted to social media and things like that, and I think some of us older guys like me have a hard time keeping up.
So when I introduced you, I said your title is Professor Emeritus, and although that is technically a correct title, I think it's a little fictional as well, because even though you retired, you're still actively teaching, and during your career you've been recognized for teaching, and you're a Giles Distinguished Professor. What is it about teaching that you enjoyed so much throughout your career and enough so that you're still doing it in retirement?
Well, you've heard the old saying, if you do something you enjoy, you never work a day in your life. And I can remember almost every day driving in, I was thinking about what was I going to do today, what was this research project, what was I teaching, what was this, what was that. And in retirement, when I retired, I planned to come back and teach. One reason, because I really enjoyed it, and I was so focused on my job here that I really didn't develop many hobbies. So I tell people now, coming back and teaching is my hobby because I have time to interact with students, and I think that if you interact with 30 or 40 or 50, 21 and 22-year-olds that are seniors in mechanical engineering, you have to keep mentally alert. So it has been a really positive aspect there.
Well, true. Well, Dr. Hodge, I want to thank you for joining us today on this episode and the impact you've had on many of us in our careers and on engineering education. It's been a pleasure working with you and getting to know you as a friend and a colleague.
Okay.
I want to thank you all for joining us on this edition of Momentum TV and look forward to having you with us next time.